So all that's ahead. The space base here covers a lot of ground, 750 square kilometers, and a lot goes on here. And all the activities that do go on here can be summed up on the right-hand side of your screen by the green panels. We call them the status panels. What they are a go, no-go, green, red resume of everything it takes to successfully prepare, launch, and follow Ariane, or Soyuz, or Vega, of course. Green means okay, red means the opposite. It's very simple. If we get a red in any of these areas, and you can see them there, these are on the wall in the back of the Jupiter Mission Control here. If we get a red in any of them, we stop the countdown. We check these panels during the first part of the mission before lifting off. They have to be green to get it going, and as you saw, that is the case. Some 1,700 people are working around the space base, and all I mentioned, it's a big base. It's a busy place. We don't have cameras everywhere, but we are going to show you one busy place. This is the Launch Control Center, where the launch management teams are working under the direction of this fellow, Jean-Pierre Barlet, the Launch Operations Manager. Jean-Pierre is a veteran. This is his 14th mission. 4 teams under him working together. 1 team responsible for launch operations, a second for flight readiness of the Ariane launcher. This team signs off on the OK to fly and on the OK to transfer the vehicle to the launch pad, which happened yesterday. A third team follows the countdown from a quality point of view according to our established procedures here at the space base, and a 4th team overseeing the safety of the people and the facilities in the launch zone. In all, about 100 of them up there. And they're much closer to the pad than we are here in Jupiter. We're about 13, 14 kilometers away, but they are right there under the nose of the launch vehicle, about a kilometer away, protected by 1 meter thick walls of the Launch Operations Center. Some other checks going on, the final checks, are happening between the launcher and its telemetry tracking and command systems to see if all is well there. We got an all systems go report that let us move into the final sequence at -7 minutes. At -4 hours, that's a while ago, tests began with the downrange tracking stations, and you'll be hearing from them soon. We had our last weather check. There are a couple of them before liftoff, the last one occurring 10 minutes before liftoff. The tanks, which we talked about, were pressurized at -4 minutes. Just ahead, -1 minute, we will make the final switch to onboard power mode. This version of Ariane is mainly for commercial launches into what they call geostationary orbit, which is where most telecom satellites go, like tonight, and the lion's share of Ariane 5's work is telecom satellites, as you probably know. There is another version of the vehicle which is used for other orbits, like low Earth orbit or sun-synchronous or polar orbit. Tonight, the 84th launch of an Ariane 5, the 273rd mission for the Ariane family. This is a split-screen image showing the propellant feeder arms, which are bringing the liquid hydrogen and oxygen into the upper stage. Liquid hydrogen is on the left, liquid oxygen is on the right. We'd just like to linger on this for just a moment because it's the last thing you're going to see. You see the yellow bars in the center of your screen going into the upper stage. They're putting the propellant into the upper stage tanks. Now you will see these arms pull back at -5 seconds as the DDO calls out. 5, of course, in French, cinq. We monitor these arms and fill the very cold cryogenic fuel down to the last minute because it boils off in the weather here, as was already mentioned. It's one of the last things you're going to see before liftoff, so we just like to mention it. We're under the 2-minute mark, and here in Jupiter, the VIPs and invited guests have moved outside to watch the liftoff. If you've been down here, you know that there are 2 terraces on either side of the building, give a fine view onto the pad. And on launches to the east, like tonight, Ariane flies right over us. And if the skies are clear, which they have been for most of the day, the visitors have a very nice view. People also line the beaches to watch the launch where the view is also good. The DDO is going to call out the 1-minute mark.
À tous de DDO, attention pour -1 minute.
Coming up in the final 60 seconds.
Stop. H0 -1 minute.
We want to say hi to all the Intelsat teams who are watching us from their offices on every continent on the globe, 23 locations in all, including headquarters out at McLean in Virginia. And we know you got 28 inches of snow at Dulles Airport over the weekend, so we hope you're all dug out and dried. Greetings, too, to our friends at Boeing, at the Boeing Satellite Development Center in El Segundo in California, where I think it snowed last in 1932, so no problem there. Also, hello to the people here in French Guiana taking the broadcast in Kourou, Sinnamary, and Cayenne. We hope you're all enjoying the broadcast. Final countdown coming up. We'll cut away and let you watch and be back when Ariane has cleared the tower.
Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage. Tous les paramètres à bord sont lumineux.
Well, a beautiful liftoff as Ariane 5 began her mission, rising into the night sky off of French Guiana, a trail of fire against the night sky, right on time, 2020 local, carrying her passenger Intelsat 29E. So we are underway. The boosters are providing 92% of the thrust, propelling the launcher along her trajectory at ever higher velocity, getting her away from the pull of the Earth. The DDO says all is well on board. And there is a lot to pull. Ariane's weight at liftoff is about 770 tons. Most of that is fuel, which she will rapidly start to shed because she's burning 2 tons of fuel every second. Ariane now following the flight program in the onboard computer, which gives all the commands, including stage separations, which we'll soon see. We are in the first of 4 flight phases. The first 3 are power, the last is not. We'll describe each in turn. Right now, the first flight phase, the single engine in the lower stage called Vulcan, and the 2 boosters are burning. The boosters will burn their propellant in just under 2.5 minutes, and they're the first hardware that we jettison. And you hear the DDO call out that milestone. We are heading out east over the Atlantic. The decision to build the site in French Guiana was made in the 1960s when France wanted to build a new base. This was in part made for its opening on the water so we can launch over uninhabited areas. See the single engine and the boosters are burning. And if the camera holds still, we can probably see the extinction and the separation of the boosters. There it is. You see the white light is the single engine still burning, and no, that can't be right. The orange is the single still burning, and the white are the boosters dropping away. Sorry about that. But beautiful shots anyway. Booster separation right on time. The onboard computer detecting that there's no more fuel in the tanks. As they have no more propellant to burn, the thrust decreases, and the computer, sensing the drop in acceleration, decides to separate them. The white light burning is the single engine of the lower stage. On the bottom of your screen, on the left, our altitude, over 100 kilometers. On the right, our speed, 2 kilometers per second, and climbing. Coming up next will be the fairing separation in about 20 seconds. And you see the logos there on the fairing, traditional logos placed there by the customers. The Guyana Space Center, Europe's spaceport, certified ISO 14001 in 2004, renewed in 2008 and in 2011. So that means everything we do here is meeting the environmental standards internationally. There is confirmation of the fairing separation. You see what that looks like. There are 2 halves actually. There's another half on the right part of the screen. Separation is given by 2 pyrotechnic systems, one horizontal, one vertical. They're cords that actually remove the fairing by a small contained explosion, and we like to emphasize contained explosion, poses no threat to the vehicle. It shears the rivets that connect the two parts and pushes them apart. We can separate the fairing now, of course, and you see Intelsat 29E exposed to the elements. We can separate now because we're out of the dense layers of the atmosphere over 100 kilometers up. There's neither friction nor heating, which could disturb the passenger. We also like to discard any dead weight whenever possible to maximize the launcher's operation. The fairing weighs over 2 tons, stands 17 meters tall. We're into the second powered flight phase. The boosters have done their work. Only the single engine burning now. It'll burn for just under 9 minutes, 8 3/4 minutes in all. Our speed is important at this moment because that's the role of the main stage. Its cryogenic propellant system, not only highly efficient, but provides a push that can last a long time. There are different propellant systems on Ariane. Cryogenics is used in the main stage, more efficient basically than solid propellant, as is used in the boosters. Basically, very basically, because I'm no engineer, solids are for getting us off the ground and away from the pull of the Earth. Cryogenics are for more precision orienting of the vehicle, and of course they also allow a stage to be reignited. That's in the other version of Ariane that we mentioned.
La trajectoire est nominale.
Everything is normal on board. The DDO continues to inform us. You can see Intelsat 29E there. That's the square box, waiting for her moment to be separated. We had a very busy year last year for all 3 Ariane space launchers, launching 6 Ariane 5s, April, May, July, August, September, October, and 3 each Soyuz and Vega. We began the year in February with the Vega and ended with a Soyuz mission in December. And this year promises to be just as full, with 11 launches scheduled, 8 with Ariane 5, so we should be approaching another record. On the right is Intelsat 29E. Beneath that, the white bands are the vehicle equipment bay, and under that, the broader white band is the upper stage. The long gray band to the left of that is the single cryogenic stage, the lower stage, and you can see the nozzle burning on the extreme left. We're going to be picked up by our first downrange tracking station in just a few seconds. That's over the border in Brazil at Natal. Natal is, we'll see the lower stage burnout and separation, as well as the upper stage ignition.
Acquisition de la télémesure lanceur par la station de Natal au Brésil.
And the DDO has just confirmed that we have picked up, that the Natal station has picked up the signal. All of Ariane's trajectory has been designed to be followed from the ground. The launcher is sending radar and telemetry back, and a network of stations keeps constant watch on our systems. Take a look at a launch replay now. Those exciting moments that took place 7.5 minutes ago. We may have another. We have cameras at several of the observation sites here around the base. So we should have more of those for you in a moment. Here's one a little farther back, speeded up image, looks like. Galileo on the screen is the downrange tracking station right here.
La trajectoire est nominale.
Talking about the telemetry sent back by the launch vehicle. Telemetry is launch vehicle data, basically. Information on parameters, 1,000 of them, being collected and transmitted back to the ground stations every second by transmitters inside the vehicle equipment bay and two antennas outside the vehicle, checking Ariane's health and performance in flight, using pressure and temperature sensors, recording all her functions throughout the flight. It's another replay, it looks like from closer up. We're coming up on extinction of the lower stage, and you'll see the nozzle, the blue flame on the left, shut down. There it is.
Fin de propulsion EPC.
DDO has
séparation de l'étage principal cryogénique.
And the lower stage has been separated, and you saw the ignition of the upper stage. These three commands given by the onboard computer in about 12
Allumage de
seconds.
l'étage supérieur.
The main stage falls back into the Atlantic. You can see what that looks like off the coast of Africa. Up in space, all is well on board Ariane. Our speed, 6.8 kilometers per second. Our altitude, 229 kilometers. The speed we need to inject the satellite will be roughly 8.7, I think, kilometers per second. So when we start approaching those numbers, keep a lookout for that. We're now into the third and final powered flight phase, a 16-minute burn for the upper stage. It'll burn until plus 24 minutes and 41 seconds. So two numbers looking ahead, 24 plus 24, 41, extinction of the upper stage, and plus 29, 42, the satellite separation. A film coming up for you now on the Intelsat group.
La propulsion est nominale. Trajectoire est nominale. Les paramètres de bord sont nominaux.
With ignition of the upper stage, we are into the second half of our mission, and we can look more closely at the satellite. Ariane 5 carrying Intelsat 29E, the world's leader in launch operations, tonight lifting a satellite for the world's leader in satellite services. Intelsat, born in 1964, the same year, by the way, as the CSG. Another film on the organization now, this time with their CEO, Steve Spengler.